Okay, so let's talk about percent yield. Um, the first thing we have to do is get a few definitions out of the way. So first definition is the percent yield. This is the percentage products produced. Okay, so this compares the actual yield or experimental yield to the theoretical yield. Okay, we'll talk about what those are here in a second. Uh, so a yield just means what you're getting out. Okay, so you're putting so much reactants, into a beaker, and how much do you get out? That's your yield, how much you actually have. So the percentage of the products produced compares actual and experimental yield to the theoretical yield. All right, so there's your definition of percent yield. So let's go through some of these definitions. The theoretical yield is the amount of product you should get. If the reaction goes to 100% completion. All right, so this is the math that you do. So, when I give you an equation and I say, well, if you're given 5 grams of this, how much of this can you make? That's your theoretical yield, and we'll look at some of those examples here in a minute. So let's talk about your actual or your experimental yield. Okay, and this is the number that you actually get. So this is the amount of product actually obtained experiment. Okay. The last one that I want to tell you about, the last definition, is what is called a limiting reagent, because you'll see that from time to time. A limiting reagent is the reactant that runs out first and stops the reaction. Okay, so if if you were making sandwiches and you had 5 pieces of bread and you had all kinds of meat and cheese, then you could still only make 2 sandwiches because you run out of bread. So the bread here is your limiting reagent. So those are your definitions. So let's look at a couple of examples. Oh, sorry, the equation for percent yield equals your actual over your theoretical yield because it's a percentage. So you're going to take what you actually got, which will have to be given to you because you're not going to actually do the experiment in most cases, divided by the theoretical yield, which is what you're going to calculate, times 100. If you get more than 100%, you're wrong. Okay, you can never get more than 100% of what you're supposed to get. So let's do a couple of examples. We're going to start out with a pretty basic equation. H2 plus O2 yields H2O. So again, first thing you have to do is balance the equation. All right, so we're going to put a 2 here and a 2 here, and then there we're balanced. Okay, so the question is, how much water produced in 10 grams of hydrogen, gas, and your percent yield was 93%. Okay, so you're going to have to do a little algebra here, I guess. So how much water would be produced if you had 10 grams of hydrogen and your percent yield was 93%? Well, you have to find the theoretical yield first. So the way you find that is the way we find it in the last video with the regular stoichiometry video. You're going to convert your 10 grams of hydrogen into water. So you're going to take 10 grams of hydrogen, and we want hydrogen to divide out, so we're going to convert it into moles. So you have 2.02 grams of hydrogen is equal to 1 mole of hydrogen. And we're going to do our mole-to-mole ratio looking at the coefficients. So we have 2 moles of hydrogen is going to give us 2 moles of water. Okay, and then we want our water to divide out, our moles of water to divide out. So 1 mole of water, we're going to convert it into grams here, is equal to 18.02 grams of water. Okay, so our moles of water divide out, our moles of hydrogen divide out, our grams of hydrogen divide out, and we are left with grams of water. So when you multiply across the top, 10 times 2 times 18 divided by 2 times 2, you're going to end up with 9.1 grams of water. And this is your theoretical yield. So if all 10 of those grams were used to make water, you could only get 9.1 grams of water. Okay, so this is your theoretical yield. Okay, and then it tells you that your percent yield was 93%. So 93% equals your actual yield over your theoretical yield, okay, which means it equals your actual yield over 9.1 grams. Okay, so figuring out, or sorry, that's not right at all. Let's go back. We had 10 grams, I messed that up. 89.1 grams of water. Couldn't read my writing. So 89.1 grams. It's okay, let's add an 8 there, right? So, yeah, you have 89 grams of water. That's your actual yield, or that's your theoretical yield. So you want the actual yield. So when you multiply 89.1 times 0.93, you're going to get 82.87 grams of water. And this is your actual yield. So at some point, you're seeing that you're losing almost 7 grams of water somewhere. Okay, whether it's through some sort of error or something else like that, but you're going to actually get 82.87 grams of water. Okay, so let's do another example. We'll give you another equation. So say we have N2 plus H2 yields NH3. So again, you need to balance the equation. All right, so there's your balanced equation. Okay, so the question here is, if given 5 grams of N2, so 5 grams of water, or sorry, of nitrogen, what is the percent yield if 7.42 grams of ammonia, H3, were actually produced? Okay, so It says if given 5 grams of nitrogen, what's the percent yield if 7.42 grams of ammonia were actually produced? So it tells you that 7.42 grams of ammonia is your actual yield, your experimental yield. And it says you were given 5 grams of nitrogen, so that's where we're going to start, okay? So we're going to say we have 5 grams of N2, convert those grams into moles, so 28.02 grams of N2 per 1 mole of N2. We want moles to divide out, so we're going to do our mole-to-mole ratio. So we have 1 mole here. Okay, there's nothing there, so it's assumed to be a 1. So 1 mole of N2 is going to give us 2 moles of NH3. Okay, and then we're going to convert those into grams. So 1 mole of NH3 is going to be 17.04 grams of NH3. So again, moles of NH3 divide out, moles of N2 divide out, grams of N2 divide out. And we're left with grams of NH3. Okay, multiply across the top, divide by the bottom, you get 9.13 grams of ammonia. Okay, that's not your answer though. That's just your theoretical yield. So again, all of these percent yield problems are going to be 2-step problems where you find one thing and then you use that in the next equation. Okay, so we're going to go percent yield equals our actual over our theoretical, okay, times 100. So it tells us in the problem that we actually got 7.43 grams out of this experiment. And through math, we figured out that we should have gotten 9.13 grams. So you divide those two numbers, multiply it by 100, and you get 81.3% yield. Okay, so 81.3% yield is your answer here. Okay, and those are really the only 2 ways that you can ask percent yield. I can give you, I can give you the percent yield and ask for the actual yield, the experimental yield, or I can give you the experimental yield and have you calculate the actual percentage. But either way, you have to take what you're given, okay, what you're given here, convert it into grams of a product, and call that your theoretical yield. Okay, so it's adding on to the last video. So in the last one we talked about converting grams or converting grams of one thing into grams of another thing, another compound, and now we're going to take that answer one step further and put it into another calculation. And that's it.